All right, so here's a quick sketch of the situation. I have a 6 kilogram block, mass equals 6, initially at rest on a horizontal frictionless surface, so I drew it there, and you push on the block with a constant force of 50, directed at 53 degrees below the horizontal. I want to know what is AX and what is AY. Okay, so the first thing I'm going to do here is actually, notice how this is below the x-axis here, right? You can draw a little axis there. I'm going to change this from a push to a pull, just because I think it makes it easy to visualize. One way you can do this is kind of continue this arrow and then draw it as a pull over here. You don't have to do this, but I think it helps, and it's a good habit to have. F equals 50, and then this angle right here, 53 below, it's still 53 below. First thing you do with forces at an angle, or with any vector at an angle, is you decompose it into x and y. So here is my fx, and here is my fy. Okay, and remember, fx is f cosine of theta as long as the angle is against the x-axis, which this one is. So this is 50 cosine of 53, and this is 50 sine of 53. Okay, so this gives me a 30, and this gives me a 40, but this 40 is going down, so it's negative 40. Okay, so I got a 40 here, and I got a 30 here. All right, now let's see, what other forces I have here? I also have an mg pulling this thing down, and I'm going to use gravity as 9.8, I'm sorry, as 10, and mg is going to be mass is 6, so mg is just 60 newtons. Okay, it's a little longer, so technically this arrow should have been longer, but I drew it smaller there. Do I have a normal force? Remember, normal force is the last one you put because you don't always have it. In this case, I have it because I'm pushing down the floor. So, since you're pushing down the floor, it's not going to break through the floor. It's certainly not going to fly up. So I can just say that the acceleration, the y-axis in this situation, is 0. And that means that the forces in the y-axis have to cancel. I got a 60 and a 40, so my normal has to be 100. Okay, normal has to be 100, the addition of the two. That's because in this case, normal equals mg plus fy. Just to be clear there. So I already got that the acceleration of the y-axis equals 0. And then the one that I'm actually looking for here is the acceleration in the x-axis. So how do I find the acceleration in the x-axis in a force problem? F equals ma. Sum of all forces equals ma. But I want ax, so I use fx. The only force in the x-axis here is the 30. So I get positive 30. The mass is 6. So the acceleration here will be 5 meters per second squared. And that's it. Hopefully you got it.